Alright, finishing up section 6.3, we're going to now look at how to factor the sum or difference of cubes. The last video we ended with looking at factoring the difference of squares. Okay, so when you have subtraction of two terms, that can be written as something squared. Difference of cubes is going to be when you have an expression, although it doesn't have to just be a difference, it can work with a sum here. But it's when you have something cubed plus something else cubed, or something cubed minus something else cubed. Okay, cubed meaning taking to the third power. So how it works, I have these two kind of crazy looking formulas, but how it ends up working is that if you can write an expression, if you have two terms, and they are something that you can write as, the first term is something you can write as cubed plus something else cubed, then it factors into the sum of those two things multiplied by the first term squared minus the product of those two things, multiplying them, plus the second term squared. And then if it's a difference of cubes, it's almost the same exact equation, except it is subtraction, the difference of those two things that were being cubed to begin with, times the first term squared plus the product plus the second term squared. And so a lot of times, usually you'll see it defined like this in math with x's and y's. If you can write it as x cubed plus y cubed is going to equal the sum of x plus y times another parenthesis x squared minus x times y plus the y squared. And the difference in the formula when they're subtraction, so x cubed minus y cubed, is just that in this first parenthesis, if it's a difference, it's going to be a difference here, so x minus y, versus a sum, it's going to be a sum there. And then you still have the first term, the x squared, and then it's the opposite sign here. So subtraction, it's subtraction in the first parenthesis, and then addition is the first operation in the second parenthesis. Or if it was addition, it's addition in the first parenthesis and then the opposite sign, subtraction in the next. So x squared plus the product, x times y, and always addition on the last term here. So plus y squared. There is a way to remember like the signs. Okay, if you can kind of remember the basic idea of, well, we're adding them or subtracting them, well, or taking the two terms and they're squaring it, then their product, and then squaring. Remember the this phrase SOAP here. Okay, SOAP is a way to remember the signs, and the way that works is that the signs go, whatever the sign is here, the first sign is the same. Okay. The next sign is the opposite, O for opposite. Okay, so subtraction, it's subtraction, then the opposite, being addition. So the same, then the opposite. And then AP, it stands for a little way to remember the last sign, and that stands for always positive. So subtraction, same sign subtraction, opposite sign addition, last sign always positive. Addition, same sign addition, opposite subtraction, last sign AP always positive. Okay, so SOAP is a little acronym to help you remember how the signs work. Alright, let's get to actually applying this now. So we have m cubed minus 8. First of all, it doesn't have to be a difference, but we do have a difference of something here. So if we want to determine, is it indeed a difference of cubes? So first of all, we are cubing m, so we know we have a cube here. But then 8, can we write 8 as something cubed? And if so, then we have ourselves a difference of cubes. A difference of cubes. So want to look at it like this. Well, we can cube m to get m cubed minus, if we cube 2, we get 8. Okay, because 2 to the third power equals 8. So we do have a difference of cubes. So we're going to use the difference formula up here. So if that looks confusing, here's how it'll work. M is our box. That's the first term that we're cubing. Minus 2 will be our triangle. That'll be the second thing that we're cubing. Okay. So let's fill this in. We have m cubed minus 2 cubed is going to be, the formula is the same sign, right? Box minus triangle. Box squared plus box times triangle. Uh-oh, running out of space here. Plus the triangle squared. Okay, so filling in what we have this is supposed to be, sorry, not squared here, m minus 2, m squared plus box is m times triangle is 2 times triangle squared is 2. Yeah, that's kind of hard to see there. I'll rewrite that. So we have the m, which was our box squared. Sorry, we're not squaring anything in that part. M minus 2 is the first parenthesis. And we're squaring the m plus the product of our box times triangle, m times 2, plus our triangle squared, so 2 squared. Okay. And we can just clean that up for our final answer. M minus 2, nothing to do there. M squared, just keep it m squared. M times 2 we can write as just 2m, and then 2 squared we can go ahead and square that and get 4. And then it kind of looks here like it might be factorable, but the second parenthesis, that's a trinomial, won't ever be factorable. So you're going to be done at this step always. Okay. So that maybe seems a little confusing. Let's try another one here to kind of try to bring the idea home. So we have r cubed plus 27. We're adding, so this is a sum. Okay. So do we have something cubed plus something else cubed? Well, r cubed is obviously a cube. And then can we cube something to get 27? Yes. 3 cubed gives us 27. Okay. So we have ourselves a sum of cubes. So this is going to equal, well, why not use this? Let's use the SOAP on this one. Okay, we're going to have same. Over here we're going to have opposite. And then always positive for our last. Okay. So what I mean by that, well, the same sign that we had here, so we're going to have addition, and our two things we were cubing were r plus 3. Then our sum formula is going to be the first term squared, so that's going to be the r squared. Now it's the opposite sign, so instead of addition, subtraction. Now we're taking the product of those two things, of our two terms, r and 3. So r times 3. And then positive, the last term will always be positive, so plus. And then triangle squared, so our second term, our second thing that's being cubed. So 3 squared. Again, taking that one step further, equals r plus 3, r squared minus 3r plus 9. So it was a sum of squares, same sign, opposite sign, always positive. Up here when it was subtraction, our final answer was same sign, opposite sign, always positive. Okay. So one more example of those. We have 125t cubed minus 216u to the 6. It's a difference this is going to be a little tricky to show if it's a difference of cubes. So you kind of want to think, the way we want to think of it is, can we cube root 125? Can we cube root 216? In other words, is there a number to the third power that gives us 125? And is there some number to the third power that gives us 216? And if so, then we probably have ourselves difference of cubes. So actually the number 5, if we cube it, will give us 125. And then since we have t cubed, we definitely have ourselves a cube. So if we took 5t to the third power, 5 times 5 times 5 will give us 125. So then the t times t times t would give us our t cubed. So that's a cube. And then is there a number when we cube that could give us 216? Yes, the number 6. 6 times 6 times 6 will give you 216. But now we have to think, what power of u to the third power will give us u to the 6. And so, maybe not initially obvious, but if we take u squared to the third power, remember this is the power to power rule, would give us u to the 6th power. Okay? Think about it over here. U squared times another u squared times another u squared. Okay, that's what it means to cube something. That'd give us u to the 6. Okay? So 6u squared, if we were to cube that, would give us the 216 u to the 6. Okay? And that's the reason why. So we definitely have the difference of two cubes if we look at it that way. So we can come in here and think of it as 5t cubed minus 6u 6u squared cubed. Okay? So, in a sense, that was our box minus that was our triangle. Okay? So that was our box cubed minus our triangle cubed. So when we actually factor this, it's going to equal, well, first sign is the same, so it's going to be our box minus triangle, 5t minus 6u squared. Then we take our box squared, our box with the 5t. We have to take 5t and square it, but we have to square the whole factor, so we have to write it like that. Plus, oh yeah, because it's the same sign, then the first sign inside the second parenthesis is the opposite, so it's plus box times triangle now, so 5t times 6u squared. And then we have last sign always positive, so plus, now we take the triangle and square it. So 6u squared is the triangle, and we have to square that. Alright, so just cleaning this up will give us our answer. Nothing to do in this first parenthesis. But if we were to square the 5t, that would give us 25t squared. Plus, in the middle here, 6 times 5 is going to be 30. U squared t. Or actually, you probably would see it written as tu squared, because alphabetical order. But it doesn't matter. It's no difference. And then if we square 6u squared, it's going to give us 36u to the 4th. Okay? So once again, we had subtraction. So we start in the first parenthesis, same sign. First operation in the second parenthesis, the opposite sign. And then last operation is always going to be positive. Okay. So that right there is how to factor difference of cubes.